Ever wondered how the simple act of waiting in line influences the world of programming? Welcome to Coded Universe, the place where code meets everyday life. Here, we unravel the mysteries of programming concepts and how they apply to our daily routines. We make the complex simple, the abstract tangible, and the theoretical practical. And today we're going to do just that with a concept that you've probably encountered more times than you can count: queues. Today, we're exploring queues in programming through real-world examples. Imagine standing in a line for a movie ticket. It's a busy day and there are many people ahead of you waiting for their turn. The line moves forward only when the person at the front gets their ticket and leaves. This, my friends, is a perfect example of a queue. A queue is a term borrowed from everyday language, and it's used in programming to describe a particular kind of structure. In a queue, the first object that enters is the first to leave. This principle is often referred to as first in, first out, or FIFO for short. It's like our movie line. The first person to join the line is the first one to get their ticket and leave. Every new person joins at the end of the line and waits their turn. This is a queue, a first in, first out structure. Adding someone to a line is similar to the Enqueue operation in programming. Let's break it down. Picture this: you're at a bustling movie premiere. Fans are eagerly waiting their turn to get tickets. You approach the end of the line and voila, you've just performed an enqueue operation. Similarly, in programming, we use the enqueue operation to add an element to the end of a queue. It's like saying, "Hey, I'm here for the show too," and making your presence known. But remember, just like in a real line, there's no cutting in. You join at the end, right behind the last person. That's the golden rule of a queue. New elements always join at the rear. So, in essence, the enqueue operation is about respect for the system, the order. It's about joining the queue at the end. When someone buys a ticket and leaves the line, that's dequeue. Just like the first person in line at a movie theater, who has been patiently waiting for their turn, finally gets to the ticket counter, purchases their ticket, and then steps out of the queue to enjoy their movie. In the world of programming, this is a perfect example of the dequeue operation. In a queue, the item that has been in the queue the longest is the first one to be removed. This is in keeping with the first in, first out principle, or FIFO, as it's commonly known. Just as the first person in line at the theater gets to buy their ticket first and leave the line, in a queue data structure, the first element that was added, that is, enqueued, is the first one to be removed, or dequeued. So, the dequeue operation is all about saying goodbye to the first element or the front of the queue. It's removing the first person from the queue. Checking who's first in line is like the front operation, and seeing the last person is the rear operation in queues. Think of it this way: you're in line to see the latest blockbuster. You glance ahead, gauging how long you have to wait. This is akin to the front operation in programming, helping you identify who's first in line. Now imagine you're curious to see who's the last one to join the queue. You turn around to see the last person. This is similar to the rear operation, which gives you the information about the last element in the queue. These operations are crucial, as they provide valuable insights about the queue's status at any given moment. So, front and rear operations help us know who's first and last in the queue. These are just a couple of the ways queues come into play in our day-to-day lives and, of course, in programming. But where do we see queues in real life, you might ask? The answer is, quite simply, everywhere. Next time you're out shopping, take a look at the checkout lines. Each customer waits their turn, with the first to arrive being the first to leave, classic queue behavior. Or consider the morning commute. Cars line up bumper to bumper, moving in a first in, first out order. That's another real-world example of a queue. But queues aren't just physical, they're a fundamental part of how computer systems manage tasks. When you click on an application, your request joins a queue of tasks waiting to be processed by your computer's CPU. It's the same principle. First come, first served. So the next time you're waiting in line, whether it's at the store, in traffic, or while your computer loads, remember, you're part of a queue, a concept that's as much a part of everyday life as it is in the world of programming. Queues are everywhere, in shopping lines, traffic, and even in computer systems managing tasks. There you have it, queues for you, a simple yet powerful concept in programming and in our daily lives. It's all about fairness and order, a first in, first out structure that keeps things running smoothly. From standing in line for a movie ticket, adding someone to the line, or watching someone leave the line after they've been served, we've seen how queues play out in real life. The enqueue operation, which adds an element to the end of the queue, and the dequeue operation, which removes the first element from the queue, are fundamental to this structure. And let's not forget the front and rear operations, letting us know who's first and last in line. But remember, queues aren't just for movie tickets. They're in shopping lines, managing traffic, and even in computer systems, managing tasks and keeping processes in order. It's a testament to their versatility and utility. So, next time you find yourself standing in a queue, think about how this simple structure is mirrored in the world of coding, and how it helps to keep our world ticking along. If this piqued your interest, there's plenty more where that came from. We're just scratching the surface of the coded universe, so if you enjoyed this explanation, comment and subscribe to Coded Universe for more. Stay curious.